Okay, now long answer type questions. The first question, if E1 comma E2 are any two events of a random experiment, and P is a probability function then prove that P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. This is called addition theorem on probability. So, this may not be given in the examination. So, in the examination the same question may be asked, state and prove addition theorem on probability. That means statement compulsory you have to remember, you have to kept in mind. Suppose E1 comma E2 are any two events of a random experiment and P is a probability function, then prove that P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. This is very important theorem. Definitely we will expect in the examination. Compulsory it may come in the examination for 7 marks. So, here first suppose case 1 here. Case 1. Consider E1 comma E2 are two mutually exclusive events. Let us assume first of all case 1, E1 comma E2 are two mutually exclusive events, because they are any two events, they may be mutually exclusive events. So, that implies therefore E1 intersection E2 is equal to pi. So, that implies what is the probability? P of E1 intersection E2 is equal to P of pi. P of pi means probability of pi. From axioms of probability, axiomatic approach, this will be 0. So, P of E1 intersection E2 is equal to 0. So, that means, so figure you get like this, the two events will be like this, sample space, this is E1, this is E2. Okay. Now, in this case actually, if E1 comma E2 are mutually exclusive events, we write from the probability axiom P of E1 union E2 is equal to P of E1 plus P of E2. Okay. Now, this can be written P of E1 plus P of E2 minus 0 you can write, that is nothing but P of E1 intersection E2, say equation 1. Now, if E1 comma E2 are two mutually exclusive events, we have proved P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. Because this is 0, it doesn't make any, actually it won't make any problem for us. So, we proved the case 1. So, let us go to the very important now. This is case 2. Let or consider E1 comma E2 be any two events, they are not mutually exclusive, any two events of sample spaces for a random experiment. So, that means this time this is the sample space, this will be like this now. This is E1, this is E2. Okay. Now, what is this one? This is the intersection part, that is nothing but E1 intersection E2. What is this part? This is E1 minus E2, E1 minus E2. Okay. Now, if you consider E1 comma E2 be any two events, then here E1 union E2 from this figure, E1 union E2 from this figure, you can write like this. This is nothing but this part is E1 minus E2 union E2, you can write E1 minus E2 union E2. Okay. Now, this P of E1 union E2 write down, that is P of E1 minus E2 union E2. Very interesting. So, this part and whereas the E2 part no common element, that means these two are mutually exclusive. So, since E1 minus E2 intersection E2 is equal to pi, you can apply probability axiom. So, this we can write P of E1 minus E2 plus P of E2. Say this is equation 1. This is equation 1. Now, here let us write E1 now. Consider E1. This E1 can be written as E2 E1 minus E2 union E1 intersection E2. Am I correct? See, this part plus this part gives us E1. If you check it, no come here also. Since E1 minus E2 intersection E1 intersection E2 is equal to pi. So, now apply the probability. P of E1 equal to P of E1 minus E2 union E1 intersection E2. Now, union axiom, you can write P of E1 minus E2 plus P of E1 intersection E2. From this we can find out P of E1 minus E2, that is equal to P of E1 minus P of E1 intersection E2. Now, from 1 replace this value. So, from 1. So, now here you see P of E1 union E2 is equal to, this is replaced by P of E1 and plus P of E2 minus P of E1 intersection E2. Say this equation 2. See, from 1 and 2. Therefore, from case 1 and case 2. always P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. That's all. So now, as it is very important, you go through it once again.